Hello, pre-calculus students, and welcome to the lesson on exponential growth and exponential decay. So let's define these functions first. There is something that they have in common. The one thing that they have in common is that it is of course an exponential function. And not only that, a has to be greater than 0. Okay? So exponential functions do not meet this description, but exponential growth and exponential decay meet this description. So this is sort of a special case of the exponential functions. Okay? So for exponential growth, we define it using limits. The limit of f of x as x approaches infinity is equal to infinity, and the limit of f of x as x approaches negative infinity is 0. So from these limits, you can picture that the exponential growth function has to look somewhat like this. And that the exponential decay function is just the opposite of that. So the limit of f of x as x approaches infinity is now going to go to 0. So basically these two limits swap. And then the limit, whoops, let me get a better marker here. The limit of f of x as x approaches negative infinity is now going to go to infinity. So from those limits, we can kind of picture that it's going to look relatively like this. So one side is exponential growth. This is exponential decay. Now we want to address some other issues here. If it's a growth function, then it has a growth rate, and the growth rate is defined this way: the rate r. Okay. Say r. Okay. R is equal to the base minus 1. And for the exponential decay, the decay rate, we'll define again the rate as r. R is equal to 1 minus b. And let me show you some examples. Let me hit pause here and show you some examples here so you can see. So let's look at this first function here. Growth or decay or neither. F of x equals 1.05 to the x. Well, you can certainly graph this. And if you graph this, you will see that it looks relatively close to this function right here. The reason is we're multiplying by a number that is greater than 1 repeatedly. So here you can see that this is the base and it's greater than 1. So this is going to be a growth function. Okay. And then the growth rate, r, is equal to b minus 1, which is 1.05 minus 1, which is 0.05. So this is the growth rate. We can contrast this to this function, g of x equals 0.87 to the x, and just to show you, you can use your grapher. 0.87 to the x. Use a standard window. And you can see that in this case, this function is a decay function. The reason is you're multiplying by 0.87 every single time, and you're multiplying by a number smaller than 1, so it's going to decay. So in this particular instance, the base, this is the base right here, is less than 1, so this is a decay function. And the rate is equal to 1 minus b, which is 1 minus 0.87, which is 0.13. In other words, you're losing 13% for every time that x increases. So let's try a few more. What if you have k of x equals 1.05 times 0.87 to the x? Now you have a number bigger than 1, a number smaller than 1 to the x. So one thing I want to point out here is that rate of growth, and whether it's growth or decay, depends only on the base. The initial value is somewhat irrelevant. As long as it's positive, it's okay. The only thing that matters when you're determining between growth and decay is what's the base. So this base here is less than 1, so this is a decay function. And of course the rate is 1 minus 0.87, which is still 0.13. So it's still the same idea. Just because you have a different number in front, it doesn't really change a whole lot as long as it's positive. If it's negative, it's neither growth nor decay. Let's look at one more function here. I'm running out of some letters here. I'll call this c of x, and I'll say this is 71 times 8 to the negative x. Growth, decay, or neither. Initially, you look at this and you think as the base is positive, but it's really not. The truth is that this is really equal to 71 times 8 to the negative 1 to the x. And remember, 8 to the negative 1 is really 1/8 to the x. So this is the decay function. And the rate is 1 minus the base. So it's 7/8. So there's a brief and solid introduction here to exponential growth and decay. In the next video, we'll take a look at a few more examples, some word problems that will help us to write these functions. Notice here, I'm giving you the function and I ask you to determine growth and decay. Next video, we're going to talk about what happens when I'm asking you to write the function.